Hello, hello, hello. कुलकर्णी ಅವರೇ
Sir, now we can join. Please join, sir.
Yes, sir.
ಕುಲಕರ್ಣಿ ಇನ್ನು ಸ್ವಲ್ಪ ಒಂದು 5-10 ನಿಮಿಷ ವೇಟ್ ಮಾಡಿ ಎಲ್ಲ
ಆಯ್ತು ಓಕೆ ಸರ್ ಓಕೆ ಸರ್ ಪುನೀತ್ ಸರ್
Hello, yeah, I'm Vijay. Vijay is speaking. I've joined. Good evening to, good morning to everyone. I've joined the meeting. I hope you can hear me. Am I able to? Hello. Hello, Mr. Nayak. Are you able to hear me? Hello. Hello. Hello, Mr. Nayak. Are you able to hear me?
Hello. Sir, you're welcome. Yes, sir. You're audible, sir. You're welcome.
Okay. I'll just share the screen once. Just check if it is right.
Sir, before that, we'll have to make you a co-host. Sir, Puneet, sir, can you do the needful?
It is done, sir.
Yes, sir. You can share the screen, sir, of yours.
Okay. Is it visible?
Yes, sir. It is visible.
Okay.
Sir, your sound should be little bit make it more, sir.
Okay.
Your volume audible. It's not audible.
How about now?
Vijay, sir.
Is it audible now?
Yeah. Yeah, you are audible, sir. You are audible, but still you can increase your volume, I guess.
Okay. How about now?
Yeah, it is fine, sir. It is fine.
Okay. Okay, are we going to wait for some more time before?
Yes, sir. We are going to introduce, sir. Please do wait, sir.
Done, sir. Done.
Hello, sir.
Yes, sir.
Dear participants, good morning to all of you. The meeting is going to start in a little while. Please do stay with us. Hello. Dear participants, the webinar is going to start within few minutes. I request you all to do stay with us.
Puneet? So Kulkarni sir, you can start.
Good morning, Principal sir.
Yeah, you can start. Later the participants will join.
Yeah, okay, sir. Thank you. A very good morning to all of you. With this pandemic situation, universities and colleges are shut down, regular classes are suspended, examinations are postponed, but the learning is not on hold at Cambridge Institute of Technology, Bengaluru. With the grace of Almighty, on behalf of Cambridge Institute of Technology, Bengaluru, I, Lakshman Nayak, Assistant Professor, would like to extend my warm welcome to all the participants for today's webinar on the why and how transition to data science for non-IT professionals. It is my privilege to welcome an educationist, a philanthropist, and a true leader, Sri D.K. Mohan, Chairman, Cambridge Group of Institutions, Bengaluru. I also extend my warm welcome to Sri Nitin Mohan, Managing Director, Cambridge Group of Institutions, Bengaluru. It is my privilege and I feel happy to welcome a true leader, a dynamic personality, a visionary, the guiding force behind the Cambridge Group of Institutions, Dr. Suresh L., Principal, Cambridge Institute of Technology, Bengaluru, for this webinar. I also welcome Head of the Department, Mechanical Engineering, Cambridge Group of Institution, for this webinar. I feel happy to have a very eminent speaker on the webinar, Mr. Vijay Shantagiri. I welcome you, sir, for today's webinar.
Thank you, sir.
I also express my deep gratitude to the management, principal, head of the department of Cambridge Institute of Technology for a very good motivation, guiding force and support to have this kind of webinar so that both student community and the society will take away something. Now, I invite Dr. Sunil Kumar N. Kulkarni, Head of the Department Mechanical Engineering, Cambridge Institute of Technology, to address. Over to you, sir.
Good morning to all of you who assembled on this August morning for one-day webinar, Why and How of Transitioning of Data Science for Non-IT Professionals. Chairman Sri D.K. Mohan sir, MD Sri Nitin Mohan sir, our beloved principal Dr. Suresh L. sir, and today's resource person Sri Vijay C. Shantagiri, CEO Analogic.in, the faculty participants, student participants from different portions of the country and abroad. I welcome once again all the participants and organizers for this one-day webinar, How and Why of Transitioning to Data Science for Non-IT Professionals. It gives me immense pleasure to brief about the conference. We all know that machine learning today, it is a hotcake technology. Machine learning is a form of artificial intelligence that enables a system to learn from data. Machine learning thus enables both the machine builder and his customers to optimize the processes. Where does the technology come from? Machine learning is an important part of computer science and artificial intelligence. Computer programs based on machine learning can use algorithms independently to find solutions to new and unknown problems. The artificial systems recognizes patterns and laws in the learning data it receives. tools already established on the market to help to find the algorithms. New frameworks and platforms support the broad applications of these topics in everyday projects. Machine learning enables technical systems to learn from experience. Algorithms are used for systems to recognize patterns and structures, with example data provided by humans. Machine learning then applies this new knowledge to unknown cases. Machine learning ensures that, anyhow, we all know that machine learning, it is a part of IT sector, but now the things are changing. The application of machine learning, it is very, very well appreciated other than non-IT departments. Machine learning ensures that software and information technology are increasingly becoming the key drives of innovations in mechanical engineering. Computer programs based on machine learning can use algorithms to independently find solutions to new and unknown problems. The industrial world is in a constant state of change. Machine learning will change mechanical engineering and thus many user industries. Implementation has already begun, particularly in case of quality control and the processes of manufacturing and in costing processes and in quality control. Now the focus is on concrete application scenarios and their implementations. In many industries, the increasing interchangeability of individual machines will mean that in future, not only the machine itself will be sold, but above all, supplementary services are also provided. It also explains why machine learning is on the agenda in management and in many specialist area of mechanical engineering. The technology offers hundreds of possibilities for machine and plant constructions. Existing business and production processes can be optimized. The machines become intelligent and almost self-sufficient process service providers. Dr. Alexander Wunderle, a famous data analyst of transition specialist, confirmed that we can use machine learning to develop new products in mechanical engineering and electrical engineering field. VDMA, Video Direct Memory Access software and digitalization also has answers for companies interested in machine learning. Basically, machine learning can be used to optimize product characteristics as well as internal processes. The characteristics of machine learning also differ with the products. On one hand, these are located in the product itself, and on the other hand, in the process environment of the machine, for example, in the form of maintenance or additional value added services. Mechanical engineers are both consumers of machine learning and critical facilitators of it. As we design and apply machines and apply physics in biomedical devices, transportation technology, manufacturing technology, costing processes, and many more. And today, at the end of this webinar, you are going to learn a lot and you can clarify whatever you have doubt with the speaker. With this, I thank the organizers for giving me an opportunity to brief about one day webinar, why and how the transitioning of data science in non-IT sectors. Thank you.
Thank you very much, sir, for briefing about the webinar. May I now request Dr. Suresh L, Principal, Cambridge Institute of Technology, to address the participants.
So very good morning to one and all present for one-day webinar. First of all, I would like to congratulate the Department of Mechanical Engineering, the Cambridge Institute of Technology, taking such a noble initiation wherein the non-IT professionals also will get insight of data science, data mining, the virtualization, visualization, and machine learning and artificial intelligence. So many technical jargons the non-IT professionals are going to the informations. At the same time, all of us should understand data is very 1 year the data is getting amplified in the sense what it is getting doubled. So it may be banking data, it may be hospital data, it may be mechanical data. In every walks of our life, we are going to handle the data, irrespective of the discipline. The days have gone where data mining, data visualization, data virtualization, all these are the property or they are the proprietary of computer science discipline. Now, see, you are seeing being a mechanical engineer, you are seeing the driverless car where the machine is going to take independent decision. So the without human intervention. See, if that the technology is moving to so extent, suppose if you move to civil engineering, it may be concreting or it may be construction. In every the civil engineering discipline, the machine learning is adopted. That is where the data science comes into picture. If you move the gaming, the see just 25 years back or 20 years back, we were all seeing the where the Mrs. Anand Vishwanathan was playing the chess and with the system. That time we were all wondering how the system can act. Now you see most of the games, the gamification softwares have been developed where the games are the users are going to play with the system, the multi-user, multi-dimensions, the games are there. Even the net, the students, the participants are sitting in the, across the tables and then they are playing the game as if they are sitting adjacent to each other. That being the technologies. And now the question is even the share market. See, we are all very busy. So we are so busy that we don't know where to invest. The which companies the share market share values are going high, which is the share values are going coming down. We don't know. We want an optimized system. The optimized system in such a way that the system is going to take decision on behalf of us. Okay, say I have 3 lakhs rupees, I'm going to preserve. My machine learning algorithm is going to invest on behalf of me. So that is where the technology is moving. And today's the topic is quite apt for all non-IT professions, wherein they will get the insight of the data, data mining, data virtualization, data visualization, and also the machine learning and artificial intelligence and so on. And of course, I would like to appreciate the Mr. Vijay C. Shantigeri, so from Analogica company, wherein he is going to spend the next 2 to 3 hours and he is going to give his complete expertise. At the same time, see the technologies. Suppose if you want to discuss with Vijay, so it is so hard for us, and he is such a busy person. But because of these webinars, because of the technologies, because of the virtual learning environment, we are all connecting to Mr. Vijay. And see, his expertise is shared to all the learners, all the interested the groups. The thanks to mechanical engineering to call such an eminent person for today's webinar. At the same time, at CA Tech, we have the minute the COVID-19 is on the way, immediately we have taken a decision to go for online learning, online education, and also explore all virtual learning environment. It may be WebEx, it may be Google Classroom, and it may be Zoom, and all the virtual learning experience platforms we explore. And also one step ahead, even we are going for the learning management software, wherein our professors can explore, can offer the certificate programs, and all our administration activities are happening through learning management system. And we are ahead of using all the tools, the Google Classrooms, Google Docs, and so on and so forth. Yes, and as and now, the last 15 days, the so many webinars have been conducted from all the departments, and even mechanical department. This is third webinars they're conducting, and the webinars are well appreciated by all the participants because the technology the transfer is happening, the knowledge, the sharing is happening, and also the participants are in a position to interact with the great experts and say accuracy, and experts can share their knowledge. See, I, as the principal of the college from Cambridge Institute of Technology, I would like to appreciate the speaker of today's webinar and also all the participants. Note down all the points and also all the VC. The PPTs will be shared and try to interact with us and motivate us so that we can conduct more and more programs of such cases. And in 2 hours or 2.5 hours, it's very difficult for any speaker to give all technical concepts. Because see, the machine learning itself we can speak for see 5 days, 6 days. If that being the case, in 2 hours or 3 hours, it's very difficult to enlighten all the technical jargons. But give us space, give us time, and also interact with the speakers so that the speakers can share his knowledge in future also. All the best. Take care. Good luck. Thank you.
Thank you, Principal Sir, for briefing us on the webinar. And I forgot to mention that our Principal Sir, Dr. L. Suresh, is also a data scientist as well, expert on the machine learning and artificial intelligence. So thank you very much for letting us know what are the opportunities are there in the field of data science. Thank you, sir, once again. May I now request our now it is time to let you know the presenter profile to you all. We have on board Mr. Vijay Shantagiri, who is a eminent speaker on the field of data science, and he is a founder, mentor of Analogica Software Development Private Institutions, Bengaluru. He has extensively worked on the field of spatial temporal information system, and is also a presidential award recipient from Dr. K. R. Narayanan. Sir, may I now request you to address the gathering as well continue with your presentation. Over to you, Shantagiri sir.
Thank you. Thank you so much for having me online. Am I audible? Okay, I just unmuted. Thank you so much, sir. Thank you so much for this honor. I thank the chairman, principal, HOD sir, and Mr. Naik sir. You also for having me in this occasion, and it's really a great honor to be here with so many participants, sharing what I've learned through over the years. Can you just acknowledge me if I am audible?
Yes, sir. You are very much audible. Please go ahead.
Thank you, sir. Okay. So first and foremost, as HOD sir and chairman sir, everyone rightly said, data science is the buzzword. It's the key area where the entire software landscape, the entire technological landscape is moving towards right now. And data science is not something which is peripheral. Data science is something where you are not moving away from your previous domains. You're actually moving into the core domain. So this whole entire exercise, or what I'm trying to present here, is to establish that connection between a researcher and the ways of data science. Because what happened with computer technology, the explosion, is all information, every observation is now being able to be seen as quantitative data. So everything that is qualitative is now being able to be converted into quantitative data. So when you have everything in quantity, you have the ability to apply machine learning and statistical models on it and predict the future. So for a non-IT person to bridge the gap is a little it's a little different, but that's what this webinar is about. It's about how and why of transitioning into data science. So I'm going to emphasize on how and why. And so shall we begin? So it's already we're into this one, so we'll just go ahead and start off. Firstly, I would like to salute all the frontliners during this COVID situation. A big thank you to all the people who are doing their best and keeping us safe. The government using all this technology, especially again using all this predictive analytics here to predict and keep us safe. So it's a big thank you to all the people. And again, a disclaimer here that all the PNGs and the graphics that I've used, I've taken it from flaticon.com, and the videos that I'm using have been taken from vdz.com, and it's a free resource, and it's my duty to give them credits. So we are from Analogica, and it's been a year since we started the vertical of online training, where we focus on emerging technologies. So our way to get into that is ideate, analyze, collaborate, build, and evolve together. So much has been said. So I'm the data scientist and founder and CEO of Analogica.in. We have a consulting as well as a training vertical going on. So the whole question is transitioning to data science. So as you can see on the picture, so the whole idea is we all want to transition, but do we have the right strategy to do it? So that's what we're going to focus on in this. So how does it pan out? What are we uh, expecting out of this transition? Actually, the entire idea of transition, the whole uh, paradigm of it, is actually change in our mindset. We've been used to a certain kind of education, certain kind of acceptance, that we do a certain thing in our degrees, we do the right formalities, and we get into it, and then we are tailored to get a certain job. But data science is not simply a job. It's more of a change in attitude towards information, and a person who has the keen interest in mystery, in puzzle solving, especially mathematical oriented. Those kind of persons really do well. So as I told you, it is about the change in the mindset. So how do you bring about a change in the mindset? What happens? From where do we start and where do we go? So we start with the mechanical nature of the world. For us, everything is moving, it's tangible, we can see things moving, right? But when you talk about information, there is a motion, there is a dynamism in information as well. So the transitioning from our previous ways of doing things, especially for non-IT, IT people have been molded already in the way of seeing things, the way of understanding information, as if it was dynamic already. But we, in fact, even I am from non-IT, right? I'm going to tell you my story. I'm also from non-IT, and that's how I changed. So what happens is you have to adapt to a new environment, a new way of looking at things when numbers are changing, right? Once you start adapting to this kind of uh, vision of the world, vision of the data, vision of the observable world, then what happens is you slowly begin to understand the inner patterns. So then mathematics starts making sense to you. So mathematics will no longer be just some equation that you solve and solve for x or solve for y, find out, do the process. Now there is a meaning, there is a reason why these maths are holding good in the realm of nature, right? So we have to achieve that, and once that is achieved, you'll be able to see graphs and progressions and be able to take decisions, and that's when you achieve your final goal of being able to take a position in any environment for that matter, where there is a lot of data is given to you, you're able to put all the right models in it and help your company make money, help your company to save money. So with that, let's get to the presentation, the story. So I would like to sort of start this session with a small story of my own, because I'm also from non-IT. So I was working as space systems engineer with IT Globe back in 2012, and I've got a master's from Manipal Institute of Technology in Space Systems Engineering. And so, despite the fact that I was into space system engineering, the kinds of jobs that I was offered and I got after that was mostly into C4ISR. So it's more like C4ISR is more like the abbreviation, the is command, control, communication, computers, intelligence, surveillance, and reconnaissance. So big word, but not much is done by a single person. It's a big team, and we're all given our work to do. And so basically, I was mostly working into areas of computers, intelligence, surveillance, and reconnaissance. So as the word is, I used to work a lot with data, all real-time data, and collect all the real-time data from the ships, from the aircraft, from all the different assets, and then somehow connect that to a stream which is going to go to a satellite, and then stream it back to what we call a war theater. When the data comes to war theater, that's when real-time analysis begins. So the point that I want to take here is, despite the fact that we are doing things which are related to defense, but the whole idea, the whole intelligence derivation happens only on data, right? So with that, with these skills and whatever acquired, I work with ISRO, DRDO, Army, Navy, and Air Force, many projects, small projects, big projects, a lot of that. So then I had a startup. We went ahead and started something for defense and space in 2015. And the first software, again, we wrote with the same background. We wrote a software called Remote Sensing Toolkit. It could do a lot of stuff with satellite data and tell you exactly at what point of time, what area on land is visible, and how we can access, how much of it is visible, and what's the swath, degree, orientation of. We used to have all the satellites data in our software. So with that, I took this software because it's a startup. So I took this software to a defense establishment, hoping that they would like it and they would purchase that software. And I got a chance. I got a chance to meet a gentleman officer, a high-ranking gentleman officer there. He was very cordial. He was very much interested. He liked what we did. But what he said was, we don't they need this kind of software right now, and what they need right now was something else. What they needed right now, that's what he told me. So I was sort of disappointed, obviously, because I had a lot of hopes. But the gentleman also told me that the kind of software, he said, he just pointed at a lot of books that were kept on his table, and he said, right now your software may not be helpful, but I require a certain kind of software. So he explained his problem statement to me. He explained that being at the position where he is in the defense sector, where he is in the area where he gets huge amount of data every day from all across, data and sense information. So he wanted a certain kind of software which could mine all the data and flag events. Flag events means there is a particular format of event, particular context of the event, right? So we build a context, and within the context you flag a certain kind of event. So he explained it to me, and then that's how my journey, my whole transformation. And so that's when I started moving away from space systems, but still spatial temporal information systems basics were still there, but we moved completely towards data science. And the first software that we wrote was FlagX. And so it could do a lot of things. It could completely take all of your data and convert it into numbers. So the first rule, or the lesson that we are going to take from here, is, what does data science do? Data science predicts But more before that, you have to convert quality into quantity. Now, an expert data science will observe the world in a quantitative attitude, in a quantitative context. Every time he sees some text, some anything. In fact, when the last webinar happened, I had a test. I think many of them may be also logged in. Last webinar, they'll be able to, So I had a test and I had a quiz, and in quiz I had given certain options. I should choose which one belongs to data science. I had a lot of options there, and I also had one option just to make sure that they get it right. So I put one wrong. I thought it was wrong option, so I put a wrong option there. The option was cooking. Okay. Now turns out that cooking is also part of data predictive analytics, because people now are able to see recipes, train neural networks, deep learning on recipes of the food, and now it is able to come up with different combinations, which is tasting good. I didn't know that. One of the students from the last webinar told me that this is true. So I mean, that's how deeper it has gone into, right? So in general, we have to understand. In general, what we have to understand in general, look at the world, look at the quality. Can you convert into quantity? Can you convert it into numbers? If you can do that, if you can put it to numbers, numbers can be put into number line. Number line can be expressed as algebra. Algebra again can be exploited using calculus to see the growth of the function. If you can see the growth of the function, you're ready to build a model, right? So it's easy for me to say because we've been doing it for a long time, but the whole idea here, the whole idea of the webinar here is to make you also feel the same progress like I'm feeling about it, right? So it's a slow process, but once you get there, you feel empowered, you feel wow, right? So we'll get there. So that's about it. That's how I changed my path into this and full time into this work. So the next question is data science the future? So let's look at this presentation. I've taken this from machinelearninggun.wordpress.com, from this website. Okay. So what all does it cover? Broadly, machine learning, as you can see, comes under these categories here. Unsupervised and supervised learning are the most broadest category that everybody who wants to transition can immediately get into it, right? So basically, unsupervised and supervised learning, there are certain definitions, but quickly, if you want to understand before we move ahead, quickly, if you want to understand, make sense of it. Unsupervised is where you already know the labels of the data. Means if you have a certain Excel sheet, and if the Excel sheets are labeled that, okay, this column is job and this column is the names of people, this is the age of people, right? If you know what the data stands for, and if you build a model for it, then it is supervised, because you're giving the system the data and also telling the system, okay, this label of this data is this, right? So that is supervised. Unsupervised is if you give system just the data and you cannot label it because you also don't know what it is. That is unsupervised. So here under unsupervised, there we can actually see a supervised system, supervised data also as unsupervised. But I'm going to give you a very interesting example where you'll appreciate, yes, this has to be unsupervised, because I come from space systems and astronomy and space system engineering. So what used to happen long time ago and even now is we have all these arrays of radar arrays, which is it's called radio astronomy, by the way. It's called radio, using radio waves. So what happens is these antennas, receivers, receive whole lot of information from outer space. Now think about it. Is there anyone sitting in the outer space sending you labeled data? If some supernova explodes and it is going to give you a lot of gamma radiation and all the other spectrum, not just gamma, it can be any radiation. Will it give that this spectrum is for gamma, this is for this one, and I exploded like this, so I'm sending you this data? No, it's all unlabeled. But still, you have the technology to receive it in certain bands and have a certain classification, a grouping of in which sector, in which spectrum is it falling, right? But you don't know what it is from. So this is the example of an unlabeled data. Now, the techniques in machine learning, very interesting, very skillful. It's more like a smart technique using all this established algebraic system, statistical models. So they use it to derive intelligence even out of the data which you don't know from where it is from. After deriving the data, you make the connections. You make the connections that, look at this. This data is somehow connected to the fourth and fifth row because this is moving and these also are moving. So when I said this is moving and these also are moving, this whole phenomena in statistics is called collinearity, right? So we understand. So what I'm trying to say is we see functions, we see growth of function. And in statistics, there are coined terms, established concepts, which are going to give us more control over the data. So that is unsupervised. And there are semi-supervised learning also. We'll come to that. A little small change in understanding. And there is reinforcement learning. I'm going to come to reinforcement learning once I finish all this. So let's look at unsupervised learning. What all can it do? Again, I'm going to emphasize, I'm talking about the question, is data science the future? So we're going to come there. We'll understand it has to be the future, right? So look at it. What is there? Unsupervised, you have feature extraction, structure discovery, big data visualization, 2D to 3D modeling, image generation, not image classification. You can generate image. You can train a system to generate image, right? Music generation, pattern modeling, all of this under unsupervised. And in clustering, unsupervised, in clustering, again, there are certain examples which is not easy just direct to tell you, but here there's an example which I think immediately you'll catch on to, non-IT people, right? Recommender systems. This is cool, right? Why? Because recommender systems are everyday things that you see every day. If you've been binge watching movies on Hotstar, on Amazon Prime, on Netflix, and if you're if you are a user very addicted to shopping online, so anytime, every time a system is recommending that since you watched Bahubali, here's our recommendation. Maybe you will like Lord of the Rings, right? How does it know that it has to recommend this to you? Do you think it is actually keeping a record of millions of people's viewing history and correlating all the million people with each other and coming out with a model? It is computationally complex, extensive, right? So there's a trick there. That's where unsupervised machine learning comes in, and using that trick, using that it's so easy. It looks complicated, but it's too easy, right? It's fun thing to understand. Using that, they recommend to you that if you like this, you like that. If you bought a bottle, maybe you like a tiffin box, right? Something like that. System knows. So that's it. So then you have targeted marketing. Imagine you're searching something on Google, and the next thing you know, 2 days later or just half an hour later, you're getting ad on the next YouTube video you're watching. You're looking exactly at that. It must have happened to you because now you've been searching data science, data science, data science. Next time you go to YouTube, you will find an ad on data science. So system is learning. It is learning what you want, right? With that, okay. So these are all okay. Unsupervised, you have seen a lot of examples. Semi-supervised, text classification, name finding. Fine. Supervised is where you have to. Supervised are systems where there are certain, the decisions are important, very critical. So let's look at where are the critical data, critical systems. Now again, understand. Critical means don't play around with the data. If you have the labeled data, if you know what the data means, then only train it. Okay, this is not a discovery mode. This is a serious thing. What are the serious things? Fraud detection, image classification, medical diagnosis, weather forecasting, right? Sales growth prediction, estimating life expectancy, market forecasting, right? Imagine if you go wrong with sales forecast, a CEO might invest in a wrong idea, lose money, economy goes down. Medical diagnosis, if you diagnose it wrong, or there's a true positive and false positive, the results. Fraud detection, banking, there are patterns where hackers and uh, loan seekers, they have a certain pattern, the system learns. So imagine, that's why when you have critical data, go for supervised learning. Now the whole world trending, as HOD sir was speaking about games and all this the systems which gives you a superhuman like smoothness in your experience. Those are all this broadly, wholly comes under AI and under reinforcement learning. Okay, reinforcement learning is actually, if you say, if there is anything hard about AI, it is this. Okay, other than that, machine learning and artificial intelligence is not hard to understand, especially if you're from an engineer. Maybe maybe not IT, but if you've had 3 years of mathematics, BCA, MCA, and engineering, I think you'll sail through with the proper guidance and mentor and discipline. You'll sail through. But despite that, understanding reinforcement learning requires a certain kind of discipline. Why? Because the whole aim of a reinforcement learning and AI, artificial intelligence per se, is to achieve something like a human-like intelligence. And it's difficult, right? It's quite a challenge to do that. But the fun part is, all the interesting part is, the first model that was discovered in 1943 was neural networks. You won't believe it, neural networks were discovered first, and after 2 years later, I think Shannon gave the communication theory, 1945. That's how far into the past it goes. So the idea was always there for neural networks, and the core of reinforcement learning is neural networks. So it's been there for a long time, but it is right now there because we have the computational powers and distributed systems and parallel computation, multi-threaded environment to bring all of that together and compute at once and give you the human-like intelligence, right? That's it. Now, again, coming back to the question, tell me, is data science the future? It has to be, because data is the future. Everybody is generating data. I mean, I just saw this one uh, statistics the other day. It said we are generating like 2.5 quintillion bytes of data every week. Quintillion bytes of data every week. That's huge. I mean, I alone from past 30 days have mustered like 40 to 50 GB of data on my system for our various activities. Imagine how much data we're creating. Your TikTok videos, your WhatsApp forwards, the posters that you make, everything is data, and it can be quantized. It can be used to understand, right? Understand about your activities and sell you something in some way. Okay, so now let's have another story which sort of gives us the historical perspective, an historical idea of where we started and what happened throughout the years and how we ended up with data science, right? So where are we here? Okay, now just to have that be true to the word, that let's start from the beginning. Just to be true to the word, I am going to start from Big Bang, because it's a good thing to start from the beginning. So this is the point at which there was no time, no idea of time. Time started when Big Bang started. So our x-axis is here, t start. So we moved, and at some point of time in everything, after everything, the whole universe settled, cooled down, all the godly acts finished, and we got the chance that Earth, Moon, Sun, everything is in the right place for human life to come about. Yes, we did that. And 10,000 years ago, the wandering humans started settling. Okay, so we're going to quickly jump to the problems of the wandering human. When they start settling, they would settle only because of the reason that they have found an ecosystem somewhere where food is guaranteed, right? So food being guaranteed, then they started rearing animals. And let me give you an example of the kinds of problems that the prehistoric man 10,000 years ago could have faced, could have, right? It's an imagination. So let's say this is a head of the family, prehistoric times, and he's got a farm. In his farm, he's got sheeps. Understand carefully. It may be a small story, but there is always something you should take out from this. So, what was the problem for this man? The problem, every day morning, he or she knows, he has to let these sheep out in the open to go graze, have food, and come back. Now, this person is standing here every day in the morning, but what does he not have? He doesn't have a counting system, right? So, what he used to do, he used to take a bunch of pebbles on the ground, hold it in one hand, and as soon as he starts observing the sheep's moving, he used to just pass on the pebbles to the other hand and throw the rest of them away. So whatever pebbles he's now having in the other hand, that is exactly equivalent to the number of sheep, but still he has no idea of numbers, right? So without having any idea of numbers, the prehistoric man was still able to have some control over his assets, right? So that's when this started happening, when these kind of problems started happening, right? Some smart guy came into the picture and said, boss, it's too much now, let's have a system of counting. So we created a system of counting. The Roman numbers came, it was a little difficult, and finally we had the system that we all adhere to now, right? Single symbol, single notation, right? So we developed the number line. The whole idea, the bigger abstraction here. Now let's move into the abstraction higher. We are moving from one level of intelligence to the next. The idea was, once you have 1 to infinity, there is also an important number called 0. I think somebody needs to mute their.
Please carry on, sir.
Yeah, 1 second. Yeah, there we go. So imagine this. Why am I emphasizing this? 1, 2, 3, 4 to infinity came because there was a need. There was a need to represent something existing. But what was the need to represent something which not at all exists, like 0? Now this is a beautiful abstraction in terms of counting itself. So of course you know it, 0, the idea of 0 was given to the world by India, right? So I'm just trying to establish that despite we being behind in technological revolution. But in terms of intelligence and abstraction, there is no way we can be behind, because we have the vision, the idea, the strength, and the broadness of thinking to absorb the world and the data and everything, to coin things together and make it happen, right? So okay, so this is where numbers come. Now you know what numbers are. You know why numbers came. Because why am I emphasizing on this? Because everything is about numbers in this world. If you want to do anything with data science, numbers are the key. Okay, not just numbers. If you just have numbers, it's not going to be enough. What about how the numbers are changing, right? So the story for that is, at one point of time when people started settling in, you also had the problem of navigation, right? A reference system. So that's when the idea of a coordinate system came into picture, right? And then it gave rise to algebraic systems, and then equations, inequalities, and all that. The whole idea, what happened is, these numbers which used to be calculated, which used to be used only to calculate a certain trivial problem of nature of our daily activities, now was able to also take its positions on the number line and give us a location, a numbered, a quantified location on a system. So if the same system is put on a map, and with respect to the north and the east and west and south, and combining with your native reference system, now you have something called a map. The same map, the concept of map, evolved into mapping your functions, right? We'll come to what function is, what a model is, everything will come. Now the next problem, so we have what, we have two problems. One, then problem of numbers, the problem of, next was the problem of coordinate systems. Next problem is the problem of the smoothness of curves, right? So what do I mean by smoothness of curves? Okay, so let's say ancient times there are two people, right? One is A, one is B. This person had a piece of land, and this other person also had a piece of land. They want to trade. They want to say, I'm going to give this piece of land to you, you give this to me, and let's say if it is a fair deal. So what do? You find the area of it, right? Area is length into breadth. Easy. If you're still not convinced, then you can just say, okay, let me divide this in so many things, and let's also divide, and let's compare how much of this is extra. So okay, so what you are giving me is this much extra. So fine, for this much extra, I'm going to hand over one sheep also to you. So we are fair. But nature is always not as simple. Your area usually turns out to be something like this. Or to be even more specific, let me go into this. Now, how do you calculate the area for this? You cannot have a length and breadth for that. You cannot have a length and breadth. That's what gave rise to. Now you have to tame this curve. That's what gave rise to calculus. Okay, because it is the area under the curve. So now slowly are you understanding that from numbers we shifted to coordinate system, from coordinate system we shifted to smoothing of curves. So what happens when you shift like that? What happens is, numbers went on your axis, and the correlation points which are relating to each other, they give you points, and this one gave you a function, this one gave you a curve. A curve is again a relationship between this and this, a relationship between these two axes. And of course, then when you want to equate it, there's going to be some proportionality constant which is coming into picture, right? This whole thing is now able to express in symbols what this curve means. But how fast is it growing? Where is it turning? How much is it turning, and how high? What is the slope of it? All of that is going to get quantized using calculus. So please connect the dot. Why am I saying this? Because later onwards you should not have a question as to what should I study to master data science. Right now in front of you, the things are clear. It's not about you by hearting equations, it's about you understanding the meaning of all this. Okay. The biggest revolution happened somewhere in 1800s, 1860s, I guess. Yeah, it's 1860, yes. 1860s, when George Boole he wrote this paper called The Laws of Thoughts. It's a beautiful paper, Laws of Thoughts, where that's what gave rise to your.
No, sir. Please share your screen, sir.
One second.
Dear participants, please.
Is it visible now? Sir?
Hello, Vijay, sir.
Yeah.
Yeah, you carry on, sir. Now you are audible.
I'm audible and the screen is also visible, no?
Yeah. Both are all right. You can carry on.
Sorry for this glitch. I'm so sorry for this glitch. So there's hoping there's no discontinuity in the flow of thought. We're gonna come back. So why am I going in this way? Why am I going like this? It's because if it was about IT people, I don't have to say all these things, because you already know the whole idea is about 0 and 1. For a non-IT person, it's about a process of changing the mentality, right? That's why, again, where were we? We were with George Boole giving us Boolean algebra. He converted representation of number into just between 0 and 1, right? Using only these two symbols. He said, only using these two symbols, I will represent any quantity that you want, right? You want 1? Yeah, I have a system to use zeros and ones to get you represent 1. You want 24, or you want any big number that you have in mind, I'm going to use just 0 and 1 to represent that number. Now, what is that number? Again, some kind of data somewhere, right? Two things happened because of this. Now, why simply getting it 0 and 1 is not a big deal. I should take my words back. It is a big deal, but the point is, what happened with 0 and 1 is electronics. The massive explosion, growth in terms of electronic computing systems, what it allowed is to bring about a system where 0 would be the state where there is no power, no energy, and 1 is the state where there is energy, right? Energy, no, you converted an entire data, entire the landscape of observation data and the quantity. So that's the evolution. That's how we got, right? That's how we got here in terms of data science. So as I told you before, we'll just quickly glance through this. So evolution of data science. Neural nets in 1943. Then mathematical theory of communication by Shannon. Now, when I say mathematical theory of communication, you might be thinking, why is this important? Right? It's very important because that's what That's where your concept of entropy came in. And entropy is such an important concept in many of the algorithms that we use in the data science. So the whole idea. Then, and for 2 years later, computing machinery and intelligence, the Turing test for non the IT people might know that happened. So it then you had knowledge, data mining, knowledge discovery in databases. Very important. This paper is very, very important. If you can just note this paper, you will get this paper actually online. Read it. It's not mathematical. It's very explanatory and very nicely written. So this is going to be a source of great motivation for anybody who wants to understand. Okay, coming back. This is where it started like booming, because it's just 15 years ago there was this article, a paper on competing on analytics, real-time analysis to know, and basically what do you do in data science. So for that I have a small presentation which is going to be a little different from so there are these concepts that we have in data science. Everywhere you'll be understand, you'll be listening to terms called data science, machine learning, data analytics, artificial intelligence, deep learning. What are all these things? So first let's get an idea about all these things. Data science is an umbrella term. You got data, you have, okay, wait a minute. So I think you're seeing the um, let me just fix that. um, okay. Okay, so we have data science. Under data science, question to ask: when you have a lot of data, but you only want to analyze the data, you want to get some insights. Means you only want to analyze data, and all you want to get is some insights. That's what you call as data analytics. You want to analyze data. So there's a position for non-IT which who doesn't want to go into programming. This is a position that you want. Under analytics, data analytics, when you have a lot of data, you want to analyze it, but the question is you don't want to code, you don't want to do any programming. That's when data analytics comes in. This is where you analyze the given data and seek patterns. You frame hypothesis and cross check if what you suspect about the data is true or false, because you have a hypothesis. Somebody says, some guy in a meeting to the finance officer, he comes about and says, sir, we're going to do awesome next year. Okay, so maybe back 20 years back, if he was a nice guy, a boss would say, oh man, my good friend has said we're going to do awesome next year. Let's put the 20 crores that we have and take a loan from bank and put it, and you don't have any proof for it, right? But right now it's not going to happen. He said, okay, you think you can do awesome next year? Prove to me with the data. Fine. You're not going to do any programming. You take the data, use appropriate techniques, and you can prove it as to where your progression is. But the key point is statistics, right? So if you don't want to code and you don't want to do statistics, then data science is not for you. You have to know statistics. And using statistics, there are so many already established systems like these statistical analysis systems, SAS systems as they're called. It's a suite, software suite developed by SAS Institute for Advanced Analysis, Business Intelligence, Predictive Analytics, Data Management, which help the organization in competitive positioning of their business, right? And one more thing, write down, if you want to write down this, because it's very new. This is super new, and if you want to just explore this, it's important, because the idea just came, this advertisement just came to me yesterday or day before yesterday when I was watching some video. It's called diligent.com. Diligent.com is a new way, a new advancement in data fabrics. So go to diligent.com and see what kind of services they are offering, and someone who there's a whole software suite they've created for empowering decision makers into taking the right decisions. Means decision makers can be CEOs of the company, decision makers in the government. This diligent.com has come up with a broad data fabric, data lake combined with big data, and they've created a system. So go and check it out, and maybe there's a great future over there. It's very new. I also don't know much. I'm also going to check it out, but there's something which came to my mind right now, so I just want to share with you. But let's not go too much. Let's just go very basic. Statistical analysis system. After statistics, if you can be thrifty with Excel sheets, if you know your way around Excel sheets like a pro, you can do a lot of data analysis. You can build your formulas, you can do many systems and models are already inbuilt in Excel. So it's called Excel analytics. No programming, Excel knowledge, and knowledge of statistics. But if you want more fancy, right, if you want to be able to present data across many subjects and many features and present it more meaningful. Maybe Excel has the limitation in how many number of features can be correlated and presented. If you don't want that, and if you want to really get into the thick of things, Tableau. Tableau is a software which is the go-to software for professional data analysts, right? Actually, is a certification, not a certificate. A certificate is something which you do a course and get a certificate, but this is actually a certification. So they will certify that you are a Tableau user. So it's a software, it's a paid software, and huge number of jobs if you are really good at Tableau and statistics. Next is R. R is also a programming language, but more for the data, more for the statistician. So it has a lot of packages in it where you don't have to code all the statistical models. R can do it for you. But right now, R is losing a little in comparison to Python, because Python gives you a broader framework where quickly, if you want to write a script, you're able to write and derive a lot of intelligence. Let's look at some examples of what I've been speaking about. Data analytics helps you in business decisions, and then helps you with hypothesis testing, then helps you with business forecasting, right? So I just skim through. Let me just understand. Hypothesis testing. Hypothesis testing is, as the word says, you have an hypothesis. As I told you, the good friend who said, "Sir, we're going to do a test next year." Remember that just 5 minutes ago? Now that's an hypothesis. So the CFO or the CEO is going to say, "Your hypothesis is that we are going to do next year, good next year. Prove it to me. Take the data of all my sales from last 3 years. Prove it to me that we are going to do good next year." That's hypothesis testing, right? So these are the broad categories under data analysis, data analyst job. Next, you have a lot of data. Next problem statement. You have a lot of data, but you don't just want to do Excel analytics with it. You just don't want to use Tableau and just visualize it. You want to automate it. Means when does it happen? In share market. Every day there's data being generated. Every day I cannot put it into Excel and do the manual job. So I want to automate it. I want to just click a button and let the data come in every day, and let the computer program run on the data every day and derive intelligence on the go, right? So in that case, that's when you start, and that's when you cannot avoid programming languages. So Python is very good at it, and Python comes up with a lot of models in it, a lot of packages in it, right? So it's got pandas, it's got xarray, scikit-learn, and NumPy is very popular. It's R visualization. Jupyter is to learn. It's a browser-based uh, IDE for your Python coding. So all of this require knowledge of ML algorithms, established algorithms, again in the context of statistics, because without statistics you cannot make sense of the results. To be a machine learning engineer, you have to have Python programming, have the knowledge of Python programming and machine learning algorithms, as I've told just before. You need to be able to understand unsupervised, supervised, and reinforcement. And under that, you have clustering, classification, regression. All of that will be easily, you'll always get resources for it to understand. But the broader idea, sorry, I missed one. The broader idea is with machine learning, you want to predict, cluster, and classify. Simple thing about it. You want to predict, cluster, and classify, use machine learning models. Now, for example, drug testing. Right? Drug testing is where a company, a pharmacy, drug company has come up with a certain vaccine. For example, COVID vaccine. Now, how do you decide that this vaccine is going to be effective uh, against COVID in all human beings? We cannot surely
Vijay,
go at. Yes, sir.
Vijay sir, may I interrupt you?
Yes, sure, sure. Tell me.
Sir, there is a voice disturbance from your end. Can you please fix it if it is possible?
Okay.
Kind of a echo is getting heard. Yeah, that
Somebody
one,
is
that
not.
one.
Somebody needs to mute because I am also getting a voice from somebody's system. So mute everybody in the room and just let my voice be on, my microphone be. You muted everyone now. Now I'm going to unmute myself.
Yeah, now you are clear. Go on, sir.
Yes. Now there is no noise, right?
No, no, it is clear.
Thank you, sir. Thank you for this.
Yes, sir. Yes, sir.
Okay, drug testing. So using statistical models and taking samples out of the population, you can have a broad understanding of how many, what is the success rate of the new vaccine that is going to come out, right? So machine learning is going to help us with predicting who can be, who's going to be effective, on what kind of people will it be effective in the population, right? Okay, movie recommendation, I've already spoken about it. Your Amazon, your Netflix, all of that movie recommendation system is built on machine learning models. Hiring patterns, this is something new where your resumes, all your projects, everything combined, everything, all of them put together is going to be converted into vectors. It's called count vectorization. Everything is going to get converted into vectors, and then machine learning models, uh, certain models like decision trees and knife based algorithm will be used to predict the hiring patterns. Means your the job portals like monster.com, naukri.com, and Indeed, all of them are going to are already employing these kind of models to know what kind of companies hire what kind of people. More so for a university context, the HRs, the placement officers of universities should employ these kind of machine learning models to position the students in their university in a better way to get employed, because not everybody is going to get a job in all kinds of uh, companies, but certain people are equipped naturally to get into certain roles. So using these kind of models, you can bifurcate, classify, and train them maybe at third semester or fifth semester itself, uh, predicting that, boss, you are skilled in this area, put more energy there. By the time you finish the college or the degree, we'll be able to give you a better opportunity and sell you to a company, right? Because that's the whole idea. You have to sell the skill. As a college, this is my student, he or she has studied so much, and this is his or her skills, and please see if you can. So using predictive analytics, you can do that, and machine learning helps you there. Moving on, stock market analysis. Of course, This is pretty much straightforward. Every data on x-axis and y-axis, the resultant vector, right? And you build a function and you predict what is going to happen. This is more like a moving number system, and here the core algorithm, the class of machine learning algorithms used are called regressions. So we're going to use regression modeling here. Now we are moving to a different kind of problem statement. We were doing machine learning so far. Now we are doing a different kind of problem statement. Remember what I used to say, what I said for machine learning. For machine learning, I said your data is complex, but what you wanted to predict was simple, like predict, classify, and cluster. But when your data is complex and you want your model to behave like a human, right? When you say behave like a human, it's just not behave like a human. It's behave like a human and have almost 99.9 or close to 100% accuracy in the resultant uh, model that is developed out of this system. So that in mind, we have to understand the major difference between machine learning and artificial intelligence. Okay, this is important for us to choose a role, and important to know what we should get into first, whether as a person we are more suited for analysis, or whether we are more suited for machine learning jobs, or whether we are more suited for artificial intelligence jobs. Let's look at it. So machine learning, no matter how complicated the code, ML algorithms cannot solve the kinds of problems that human beings can solve, right? It can be complex. You are able to use many multi level systems together simultaneously, concurrently, but still getting that kind of human smoothness is not possible. To make a machine learning algorithm mimic human thinking, the models have to be more complicated. And that's when there was a need for a system which was not just merely an algebraic system, right? You wanted a multi-dimensional system. So that's when the idea of neural networks came in. Neural networks. Whole idea of neural networks gave rise to deep learning. What again, in deep learning, don't think that you don't need statistics. Of course, to appreciate, even to get a smallest insight into what is happening in that particular strand of the network, you need to know statistics. And there is no option but to know Python or any programming language, because I'll come to you why it is so important to have the programming language there. And then you have to have the knowledge of neural networks. And neural network is a little different from machine learning. You have layers here, but one thing I can tell you about is each of this layer, what the circle that you're looking at, each of this is a function. In machine learning, you build one function, one growth function, right? But in neural network, you're building all these growth functions at once, and all of them are growing, trying to learn from the data, and finally a few of them get selected to be the best ones. It's nature, but it's a beautiful thing. It's like, AI deep learning is like Brahmastra, or what, Vajrastra or Brahmastra in Mahabharata, right? I mean, if you use a Brahmastra, then of course it's going to get the enemy is going to get killed, right? So it's like the Brahmastra of AI, artificial intelligence. Any problem, anything it can solve. But the problem is sometimes you have to take a decision as a data scientist why you want to take up so much time and model everything when machine learning models can do, why you want to go for deep learning. So that's a decision a data science and a team can take. So the first instance, the first way, or the most easiest way for you to understand deep learning is go to TensorFlow Playground. You can Google TensorFlow Playground on Google, and then you'll get to this website, uh, and there you can play around creating new layers, hidden layers, and a small statement, problem statement is also given over there. Play around with that and understand. and then you'll get a good idea of what deep learning is, what neural networks are. So what kind of examples are we looking at here? What we're looking at with AI, what can it do for you? Self-driving cars. If you are into the automobile industry as a non-IT person and you want to move into data science, this is the area which is picking up rapidly, right? And you can only appreciate how critical these things are. I mean, there is no room for error, absolutely no room for error, because the collateral damage is going to be something which no company can bear. So, but this is possible. Look at what kind of classification. Now, neural networks could classify between a cat and a dog, but deep learning networks can classify between a cat, two different kinds of cat, a dog and a duck. Right? All of these features, imagine the amount of features it is able to extract from the given data and come up with a model to classify it. Next is speech recognition. All human like, right? That's what I'm trying to tell you. AI and machine learning, AI is all human like activities. First, we had self-driving cars, then we had image classification, because our eyes can classify, our eyes can see across the room and say this is a table, that's a curtain, that's a door. It's easy for us to achieve that kind of smoothness into the systems. That's where artificial intelligence under the bracket of AI, that's where it is. So speech recognition system, can anyone tell me an example of speech recognition where it is used? Your Google Home device, Alexa, right? It can recognize your voice, and it is so trainable, so flexible, that close to 10 to 15 people can have a unique identity of theirs registered through their voice on this system. So if I ask my Google Home now, what's my name? It's going to say Vijay, because it has analyzed the patterns. Now, what happened again? Audio is going to give you the mathematics to convert my way of speaking, my variations in my voice into numbers, and putting out this system, putting out a model which can recognize my voice. Okay. Of course, next is disease prediction. So not much different from all other systems. Again, all your uh, health data is again in terms of numbers. Your the BP and the diabetics, everything that is collected out of your blood sample, everything has a number, right? So once you put all those numbers together and train a model and give it a lot of past data, then it is going to build into a system which can predict whether a certain combinations of the blood pressure, the diabetes, the fever, and the peripheral pains, or the dislocations, or the skin color, anything, right, can lead to certain problems in future, right? Pulse rate, heart rate, so many things are there. All this data you have to be able to put it together into a context. So this is about it. Now, coming to the main area of we sort of established now as to why data science, right? So how do you transition? How do you transition is what I want to address now. Starting off with the idea of the skills and salary in the field of data science, right? So let's look at the machine learning engineer. These are all open for a non-IT person, okay? These are all open positions for somebody who's from non-IT. They can learn a certain skill and enter this domain. So what are you expecting with the machine learning engineer, roughly about 8 to 12 lakhs per year package. And the programming skills required there are moderate, not too high. But there is something called a Panda and a Python package, right? In Python, there's a package called Pandas, and this particular Pandas, remember this, because if you are going to take up your own uh, path, you have to understand that mastering this particular thing, this particular skill, is of highest importance. Why? Because Pandas is magical experience of Excel sheet. It's just like Excel. It's just like your database, but it gives you a magical experience. The kinds of things you can quickly do it in 2 or 3 lines of code and manipulate data, shift from here to here while shifting, calculate the standard deviations and multiply it with variance and just put it 2 lines of code, right? Of course, you can do a lot of things, but you should also know what to do, right? So what to do as a machine learning engineer, what to do will come to you from your data scientist, because you'll have a project manager who will be a data scientist or an artificial intelligence engineer. They'll all be experienced. If you're looking for an entry level job, don't worry about statistics and don't worry about I don't know this. Just worry about whether your programming skills, especially in Python, are good, and whether you are able to hold your own on pandas, right? Then ML algorithms, moderate. How good should you be at machine learning algorithms? Moderate, I would say, because although as a part of your training, wherever you get trained, you will know the internal working of a machine learning algorithm. You'll know that these kind of algorithms are applied here, fine, but nobody is going to come to and expect fresher or a 1 year experienced person to go and tune any algorithm from inside. You have a team for it, but they'll expect you to know that if they want a naive base algorithm to be applied, they'll expect you to know where to find it on Python, which package is going to give you that. They'll expect you to know it. So the know-how, that's why I said moderate, right? And then there is something called object-oriented concepts. So this is also moderate, because you are not building any big-time software systems or a product out there. It's pretty much straightforward, just using a procedural way to build a model. So oops is not much necessary. Why am I saying all these things? Because I'm saying that transitioning into an ML engineer should be the first attempt for a non-IT person. Because it is not such a big bridge to cross. Now, can you do away without mathematics? Can you do away without statistics? I would say no. You have to have minimum understanding of the mathematics related to machine learning models, minimum understanding of statistics, both inferential and descriptive. Now, big data and Hadoop concept for an ML engineer could be minimum, because you are not anyway brought into this category. The whole concept that you'll be working on is data is going to be given to you. You have to pre-process. Pre-processing means remove noise from the data. What is noise, you will understand later, but understand that data comes with a lot of noise, means a lot of biases. So you have to remove that, and pre-processing, removing noise, all this is pandas. So trust me, you master these two, you are in a good position to transition into data science. Now, AI engineer, that's the next position. AI engineer of roughly about 3 to 6 years experience in the industry. You hit a salary package of roughly 15 to 22. I think it's even more now. An AI engineer is somebody who's usually from a domain, actually. Okay. So when I say domain, And when I say AI, recall what I said last time. AI is more about achieving human like intelligence. Okay? But humans do a lot of things. What intelligence are we talking about? Are we talking about driving cars? Or are we talking about recognition, being image, be it image or voice, doesn't matter. Are we talking about recognition of something? So look at this. They all come with their own domain. Just a computer science guy cannot come and become an AI engineer for building driverless cars. Why? Because the person needs a domain. The person who is from automobile engineering and also has AI expertise or ML expertise is going to be an AI engineer in the field of self-driving cars, right? Somebody who's from image processing, somebody who's from signals and systems, electronic engineers, signals and systems, image processing plus machine learning, you can recognize images. Signal processing and machine learning, you'll become great at voice. Now, so understand, AI engineering is not just machine learning engineering. It's not machine learning or pandas or Python. You cannot be a computer science person directly cannot become an AI engineer because AI comes with a context. AI of what? Artificially intelligent in what? You can ask. So just imagine what all things can you do, right? Even lawyers, even lawyers now are taking courses in AI because they want to mind the entire laws. There are softwares now. The moment a case comes in, for a lawyer, imagine a case comes in, a lawyer has to think, okay, how do I convince the judge to win this case? So the way to convince a judge to win a case is by reading up a lot of other cases where the judgment was made in the favor of his client, his or her client. Now, instead of going through all the books, yes, they will do because they'll have certain cases, but an expert level analysis of the entire textual documentation that is available for the lawyers, if they put it in the text mining context of AI, then you have ready answers given to you. This was done like this was done like this, right? That's where the world is going. So AI engineering, remember, is domain engineering. And I'll give you something called a very nice representation, right? Picture of it later. It's just down. So I'm going to tell you. And I share that picture also with you guys so that you'll always have it in front of you. Moving next. What happens with AI engineering? What is expected? Look at the red color thing. Red color box here. Programming skills. High. No, very high. You have to have high level of programming skills for this because the system that you're modeling is not a simple system and a simple procedural system cannot uh, solve it, and a simple scripted system on a Jupyter notebook is not going to solve it. It is a system software that you're building, right? So you require high levels of programming skills. And pandas and Python packages, of course, high. ML algorithm skills, high. Why ML algorithm skills are high? Because here you're not just applying a machine learning algorithm, you're tuning the insides of the mathematics, right? You are taking the mathematical, you're not calling a package. Remember, you're not simply calling linear regress this value. You're going to take the algorithm of linear regress and you're going to add more layers of computation inside it, which suits your domain, because every domain comes with its own problems, peripheral problems. You will have to take data analyst. You already know, I've already spoken, not much to say about it, because it is not about programming at all. So nobody expects you to know programming in data analysis, and nobody expects you to know pandas or Python. Machine know the inner workings of every algorithm, to know how that algorithm is treating the data. How is it able to classify? How is it able to cluster? The inner logic of the mathematics, right? It's important. for a data analyst also. Okay, so since there is no programming at all, oops concept is minimum. And look at this, but it's all in blue. Intuitive mathematics, high. Inferential statistics, high. Descriptive statistics, high. Tools like SAS, Tableau, Excel, you have to be master at it. So you may not be expected to know much about these programming and these aspects, but definitely you need to be a master at these aspects. Okay, so these are very, very important. So this is before I end this whole this strand of discussion, I want to quickly give you broad insight into what are you getting at, what are you getting into when you're talking about data transition. There's a very beautiful graph which is an extension of Drew Conway's data scientist Venn diagram. Right, Drew Conway is uh, an expert. He's the CEO founder of Illuvium company, which gives insights to business. It's a big name in industry, and Drew Conway came up with a Venn diagram, and this is an extension of it. So basically, a data scientist broadly has these skills: communication, statistics, programming, and business. Business means domain. I talked about domain. Domains are, your domains can be automobile, E&C, mechanical engineering, aerospace, law, or even you may be a chef for that matters. If you are good at it, you should be so good at it that you can see the process and see the numbers changing over there. Numerical computation. If you're so good at it, then that's what your domain is. With this, if you combine programming, statistics, and communication, that surely you are into data science, right? So I want to, because this is about data science transition, I want to get your attention, your full attention, hope so, into this particular aspect here. The perfect data scientist. What does it mean to be a perfect data scientist? Okay, let's look at it. If you only know communication, right? Let's say you only thing that you know is communication. So where is that? Only if you know only communication, what part of your, this is the part, right? So if you know only communication, you don't know nothing, and all you can do is communicate, then that's what you are, hothead, right? But if you know communication and you know programming, then you'll be a computer science lecturer, professor, right? You can teach. You know something, you can teach, you're a professor. And if you know programming, if you know communication, you also know business, you're a head of IT. So I'm going to share with this screen. We don't have so much time to go through all of it, but just look at where the perfect data scientist lies. It is on the cusp of business, programming, statistics, and communication. So why am I here? Why am I explaining this? Because I wanted to come to the next level where we are talking about what is data scientist package. Close to 30 to 45, close to even 60 lakhs per annum. That's huge, right? Why? But why? Why are they paid so much? Because they know business, they know programming, they know statistics, they know communication, all of these things. So it takes years to get there. And when I say business, make sure, keep in mind, I'm talking about not just business, it's about domain also. If you are an automobile expert who knows programming, who knows statistics, and communicate well, you'll be a perfect data scientist in the domain of driverless vehicles. That's how it works out. Okay. So when I say transitioning from non-IT to data science, make no assumptions or mistake that you are not going to leave your present domain. What you've studied is not going to go waste. If at all you've really studied and understood your subject, then AI, machine learning, is going to be an enabler for your present skills, because that's where the whole world is going. So the sooner you transition into data science, the better it will be for you to be ahead of the curve, and other people or other competitors in this field will come to you, or come to the competition. So let's look at a broad skill levels required. Programming skill moderate. Programming skill moderate. But why am I saying expected is moderate, but the person will know a lot of programming? Expected is moderate because a data scientist doesn't work alone. Okay, he'll have a team. A team will comprise of machine learning engineer, AI engineer, data analyst. All of them will be there in his team under a data scientist. He or she will lead the team and will give jobs to a machine learning engineer to go and do the programming, go into the pre-processing, right? So expected programming skills moderate. Nobody is going to interview a data scientist on their programming skills. Pandas and Python packages, nobody is going to interview. They will know, but not at you know at the recallable stretch, or it's like a speed dial on your mind. It's not going to be that. But of course, when the things get hot, they will dive into it and they'll solve it. But what is expected and interviewed very highly is machine learning algorithm skills. I mean, to the level that a data scientist should have at least 10 to 15 papers published in some journals, acceptable journals, on machine learning algorithms and certain variations of it. That's expected. Mathematics, of course, high, because if you're at the level of writing papers, then should be very comfortable in reading other mathematical papers on machine learning and AI. Inferential statistics. I've been talking so much about inferential and descriptive statistics. I'm sorry, didn't occur to me that I have to explain what is inferential and descriptive. Descriptive statistics is the statistics that you learned under statistics in your school. There was a time when you learned something in the school, all the cumulative frequency, OGs, and standard deviation, all this describe the data, right? Inferential statistics is something which commerce people or people who take statistics as a subject learn, because you are going to infer something from the data, not simply describe how the data is. You're going to infer something, and using that inference, you are going to do a prediction, right? So that is inferential statistics. Models, ideas are different, and descriptive statistics are different. First thing you learn is descriptive. On that, you build new techniques and get into inferential statistics. So both of them are required highly. And tools such as SAS, Tableau, Excel also preferred very high. Not very high. High. They should be adapted, and so that's where we sort of end this section and quickly move. So at this point of time, sir, Naik sir, hello, Ms. Naik. Hello.
Hello, am I audible, sir?
Yes, sir. Yes, sir. You're audible. I was
Yes,
just
sir.
wanted
Yeah,
to know,
shall
shall we go for a question and answer session, or do we have time for the next session here? Because
no, sir. No, sir. Let's go for the any questions if the participants are having,
surely.
so that you can answer them comfortably. Yeah, now participants, you are open to ask any questions if you have.
At this point of time, what is
No, no, no.
Sir, we
ಸ್ವಲ್ಪ
have we have to
ಒಂದು ಸೆಕೆಂಡ್ ಒಂದು ಸ್ವಲ್ಪ ಮ್ಯೂನಿಕ್
Hello.
Yeah. We.
Hello.
Yes, sir. Please tell me.
I have a question, sir. Yeah, you spoken so elaborately. So even though the person who is non-IT can enter into the data science, but what would happen is over a period of time, the one who is not in contact or in touch with the programming part, okay. So what is a pathway? What are the ways in which he can enter into back into the programming skills? Because he is in IT for say 5 years, he is not at all in contact with the programming skills or logical thinking. So, is there any platform that can give him a way so that he can enter into the better way of understanding or get into the data science? Because data science has lot of domains to be covered to be successful in the domain. That is why I'm asking this, sir.
Excellent question. Are you able to hear me?
Yes, sir. Yes, sir.
Excellent question. The question I was wanting to address it because I realized that the biggest hurdle for a non-IT person is the fear. I'm going to address that. I have a beautiful slide for it. Let me get there. Okay.
Thank you, sir. Yes, I will be waiting for that, sir.
Yeah. Yeah. I'm already there. Are you able to see this?
Yes, sir. Yes, sir.
The biggest psychological obstacle for non-IT professional is fear of computer programming. Okay.
Yes, sir. Yes, sir.
So it's like we are often because I relate to it because I was like this once. I was like this once, trust me. And the reason I learned programming is because for the love of the subject that I had, the love of the subject of computational systems, space systems, astronomy, it required me, it was required of me to learn all these things, to automate these things, right? So so you're asking me how difficult is it to
No,
transition?
sir. What is a pathway, sir? Because it is difficult for anyone to get into the new domain. What are the pathways or the avenues for the one who want to enter into the data science from non-IT to the data science?
I'll tell you.
What
I'll
are
tell
the
you.
pathways for him?
I'm going to address. But the idea is because I've started this trend, so let me just finish this. If
Yes, sir.
maybe you for you it may not be difficult, but there are many people for whom programming is a hindrance. So I've got this one which says that it's more about your thinking that, and it of course this is also an answer for you in a way. Look at this. It says that human brain is a reverse entropy engine. Okay, human brain is a reverse entropy engine. Means entropy is what? Chaos in a system. Human brain has a natural ability to go into the chaos and find patterns, right? So our biggest worry, in fact, your question from your thing that is coming from you also, the biggest worry is somehow we think we consciously have to learn everything. So are you able to hear me?
Yes, sir, he can. He can. Please go on,
Yeah.
sir.
Our biggest worry
Yes,
is
sir.
that we consciously have to learn everything, right? But the truth actually is that it is our subconscious mind which learns. And if you do something long enough, your brain is designed to make the neural connections. And these connections are the physical proof of learning, right? So what are those things that you have learned like this from past? If you're able to write today, it's because of this subconscious evolution that you happened. Driving, swimming, remember anything that you learned is because of it became a habit. So the whole idea is faster transition. You don't have time. You don't have like 10 years to do the transition, right? The key point to take from here is to train the subconscious mind faster, we need a structured approach. And the knowledge fed into our brains must be layered, followed by sequence of tests and the required strengthening required for the learning that you've had. Means start any course, but don't just learn. Allow yourself to be tested. You learn something, take a quiz. Take a course where you are frequently going to be put into test. That builds confidence. Now, talking about the pathway for a non-IT, where do you start? Where do you start from the scratch? So, starting is choosing the right mentor. Mentor means you don't choose a course, you don't choose something which is free, or just because it is free, you're not going to do it. There are many free courses which are very good. There are many paid courses. That's the most important thing. Under Python, focus more on pandas. When I say Python, essential Python has to be covered. If you're completely from non-IT,
When I say Python, essentially,
okay, am I audible?
Yes, sir, you are audible.
Okay. If you're completely from non-IT, there's a problem. Because directly shifting from non-IT to a programming language is going to open up problem areas later when you're into IT. You'll always feel in your mind that you're a non-IT, I'm doing programming, all others around me are from computer science, they know so much about me. You need to somehow answer that question to yourself, right? Because if you're not bothered, you're insensitive about these things, and you just go walk through it. But if you are the kind of person who's always feeling inadequately prepared about these things, so you have to bridge this. So from non-IT to programming, some important things under IT. First, understand the idea of computing. Very important. How does a computer actually compute? Understand everything about how internet works. Not simply some video. You should think about it. Where is the data coming from? What is the data server? How it is changed? Understand object-oriented programming. What is an object? What is a class? How the data was modeled there? What is happening over there? Why it is like little bit. Ask someone. Find somebody from computer science and ask them to give you a lecture on or a 3-4 days expose on operating system.
Yeah, can we move on to the next question? If anybody are having?
Sir, shall I ask the questions?
Yeah, go ahead, sir, please.
Sir, what are the one is online software which are available for learning the data science and which would help to us testing ourselves? Yeah,
Yes, sir. His question is about what are the available softwares and resources through which one can have the confidence before one
yeah,
transitions into the data science. Am I right, sir? Is it your question?
yeah, that's true. And
Yes.
we can test ourselves through online
Yes,
about the data science and for the non-IT.
Firstly, Anaconda is an IDE. IDE means integrated development environment. Okay. I understand from non-IT when these terms comes in, it's a little difficult to follow through. It's as the word says, it's an environment which helps you to develop, right? So Anaconda is a framework. It is free. It's open source. You can download it. And I'm also going to share with you. Are you able to see this screen in front of me? It says
Yes, sir.
Jupyter COVID
Yes, sir.
prediction,
We can
right?
see.
So Anaconda gives you something like another package in Anaconda is called Jupyter Notebook. So this is where most of the people code in and test their results. So Jupyter Notebook has a unique feature in it. You write the code here and your answer is out here. And the next slide, right? There is input and there's an output. Then after that, there is a next layer of input, then there's an output, and after that, there's next layer. This is modeled, this has been built specifically for non-IT people to transition into data science. It is used extensively even by professionals because it is so easy for somebody to just save this file and send to another person, like a Word document. You keep sharing Word documents between each other. You can share Jupyter files between each other, and all the code will be there, all the comments will be there, what you did, what you did not. So you try doing something, you fail at it, you're not able to explain your problem, you find a mentor, you save your Jupyter file and send it to them and say, can you please just let me know what mistake I made? They will be kind enough to comment there and send you back the file. You can run the file again and see the whole thing. That's how flexible Anaconda and Jupyter. This is used everywhere. This is a standard now. Okay, if you're going to learn this, you're learning exactly what everybody is learning. Okay, this is the standard of this. So hope this answers the question of what are the online softwares available.
Yes, sir.
Don't go for anything else, just go for Anaconda and starts with Jupyter Notebook. Now, just software is not going to help you. I also have a collection of introductory books that you should learn. And these two books, if you can take a picture of it, just click with your mobile phone or any way you want to store it, it's up to you. Available on Amazon. These are I don't know any free resources of it, but it is readily available, and I hope you will invest on these two books without going for a e-copy of it, because these two books are very important, and it's best to have an e-copy. Roughly it costs around 250 or 300.
Yes, sir.
A worthy investment. Use a pencil and write your comments on the whole book. It doesn't matter. You can buy a new book if you want to put it in a library, but buy this book, and wherever you are, bus, train, metro, home, keep reading chapters, keep making notes on it. It's going to help you to bridge the gap. Okay, any next question, please?
Yes, sir. Anybody else with any sort of the questions? Yes, if there are no other questions, can we wind it up, sir? Sir, Puneet, sir?
Yes, sir. Yes, sir.
Yes, sir. On behalf of Cambridge Institute of Technology, I would like to immensely thank our eminent speaker for excellently presenting the history, evolution, as well the way in which one can transition into the data science. Sir, it was an excellent presentation. We thank you, sir, very much for having on the board and letting us know the various avenues behind this data science. Thank you once again, sir.
Thank you, sir.
And on behalf of Cambridge Institute of Technology, I thank each participants for attending to data science from an non-IT field. If any participants have got any unanswered questions, we will get back to you in a day. You can have your questions answered. Thank you all for attending this beautiful webinar.
I also had something.
Thank you,
Have a
Lakshman.
good day.
Sir, I also
Sir,
had one
thank
more.
you, Nagaraj sir, for attending the webinar. Thank you.
Hello, sir. I also had one more thing to add.
Please go ahead, sir. Nagaraj sir, please.
Sir, this is Vijay. I
Yes,
just
sir.
wanted to add something.
Yes, sir. Please,
To
sir.
all the participants who are
Yeah,
interested
please, sir.
in
Please go ahead, sir.
transitioning, we have a course starting on June 8th as our training vertical, and it's called Machine Learning Fast Track. Okay, it's not a lengthy course. It's just a 15 days high energy sprint, and it is. I'm going to send you a link for it. So we are giving it at 50% off. Okay, so in just about 1999 you can register.
Okay,
for
sir.
15
The
days course.
details will be shared with.
Yeah, we'll send a details of.
Yes, sir. The details will be shared with all participants. Thank you very much. Have a good day, all.
Thank you so much, everyone. It was a great webinar to be interacting.